Anyway, as I said last lecture, we're talking regarding how to convert from binary to decimal and decimal to binary, octal to binary, and all these. And now what we are going to do is that we are going to show how we can have the sign number, means that positive or negative number, because this will help us to do the arithmetic word, something like subtraction or addition between the two binary number or any other base number. What today we will talk is that first of all, how we can have the meaning to the negative or positive sign. I mean that if I have the positive number or negative number, how I should show it. This is the main thing. First of all, you should see that we have the table, something like that, and some specified rule that in that we can say that what should be the summation of 2 bits. This addition that we are going to discuss is exactly bit by bit, means that 2 bit we can add or 2 bit we can subtract. As I show you in this table, uh, if I had the 0 and with the 2 0 that we want to add together, 0 plus 0, it's become to 0. 0 plus 1 is equal to 1. And 1 plus 0 is equal to 1. And 1 plus 1 is 1, 0. These more bits, we call it carry. This is something that we are going to see and discuss today regarding it. Let us do exactly one example. Suppose I have this number 1101 and 0111. Now I want to do the summation for that. As the previous rules tell me that 1 plus 1 can be 1 0, means that I should have 1 0 at the end. And if uh, I have this one, it means that the other parts means that from here 1 plus 1, I can have 1 0 here and another number will go at the top. Then 1 plus 1 as the next steps I had, because I have now 3 numbers, 1 0 and 1, then the summation of that it's become again 1 0. Okay, something like this as I show in the downside, as you see. And then 1 plus 1 plus 1, instead of 1 0 it's become 1 1, and then 1 0 it's become 1 0. I have one more number which we call it carry. Okay, the summation that we have done that was based on this part 1 plus 1, we call it as the carry, which it's happened for us in several times. Sometimes we had direct, and sometimes I had in the number which is happened by carrying from the other part. Uh, let us see for more example what will happen for subtraction. Please note down first of all these rules. Just think for that. Have a look. What is the difference? Different is in the last case. In last case, 0 minus 1, it's become 1. And 1 0, 1 minus 0, and 1 minus 1, it's become 0. Okay. And next example, we will see here that 1 minus 1, based on my rule, it should become 0. 0 minus 1 should become 1. and 0 minus 1, it should become 1 again, and then 0 minus 0, it should become 0. Okay, everything is from this. But what we call these, we call this as the borrow number. Means that suppose I want to take the number from other part and then use it uh, for the next. Okay, analyze these. Let us do for another thing. You know, this part is exactly same as the decimal job that we have done before. In the decimal job, what we will do, in the decimal job also, we are doing the same things. Uh, in the same job, suppose the number 1, 2, 3, 4, and with the summation with the 5, 6, 7, 8, we will do the same job. 4 plus 8, it's become something like 12. Okay, then 2 is at the down and 1 is at the top. And then again, we have 3 and 7, which should come again. We have the one more 1, which should become as the summation. And then we have as the uh, 1 will come here and 1 will come for the next. You will see at the next round we have 2, 6, and then plus 1, which it's become 9. And uh, for again next round we don't have any carry part, which is become 1 plus 5, and it's equal to 6. Okay, please see these. Okay, you know, actually for the elementary school also they teach us rule. Means that if subtract the number, we have the terms of borrow, and if we want to do the addition, we have the same terms of carry. Here, same things and same rule will happen for the binary section part. Okay, that is the case for the decimal. Now, what will happen for the binary? For binary also, we expected the same thing. What was the rule? The rule was that 1 plus 0, which is become to 1. Then 1 plus 1, we say that it's become 1, 0. My 0 is here at down. And then at the next round, I have 0, 0, which will be added with a 1, which become 1. And then 1, 1, 1, it's become 1, 0 at the end. Let us see what will happen for subtraction. For subtraction, it's very simple. 1 minus 0, it's become 1. 1 minus 1, it's become 0. 0 minus 1, it's become 1. And 1 minus 0, it's become 0. Okay. As I even written in this part for you, in decimal, we are quite familiar with the placing the negative sign in front of the number to denote that the number is negative. Zero, 1, 1, and then I have 0, 1, 1, 1, 1, 0. Okay, I want to do the summation for them. For the first one, there is no problem. 1 plus 0 is 1. 1 plus 1 is 1, 0. 0 is there, 1 will go there. 1 plus 1 is 1, 0. 1, 1, 1 is become 1, 1. 1 will go for the next round. And then at the next round, whose I have 0 and 0, 1 will add to that. And then 1 plus 1 is 1, 0. And you will see here what 1 is extra, because I restricted myself that I should be in 7 bit. Okay, this is my main problem, as you can see, that my bits it's become more. Okay, then what we should do today, we will talk for this problem. If we want to write the negative numbers, we have some way. One is that prefix number with the minus symbol, how we should show it. Okay, we have three approach. One is that sign and magnitude, means that one specific bit I can put, and through that I can show that my number is positive or my number is negative. Okay, it could be one method. One method could be one's complement, one method could be two's complement, and these are the way that by that we can find and shows the problem with the negative and positive numbers. Okay, first of all, I request you that you convert number 12 into the binary. Convert it, please. How can shows the look to this slide number. Okay, what the difference between minus 12 and plus 12 here? The main problem is this bit. The main difference is this bit. This bit we call it MSB, or most significant bit. Means that the bit will show us that our number is positive or my number is negative. But how many representation we can have for zero if we have this method? See the table? In table I show, suppose 0 is equal to 0, 0, 0, okay? And then what about minus 0? If I put the number 1 as the sign of the minus, and I put the last bit, means this MSB part, for the positive number, like this, I have two number which shows positive 0 and negative 0, as you can see here. Then it's little bit problematic. Yes, for the maybe other numbers there is no problem. Suppose you see minus 7 and plus 7 here, not much more problem. Okay, or plus 1 and minus 1, again not much more problem. Hmm? Then first of all, as the first approach is that putting the MSB part as the sign number and show it as positive or negative, maybe it has some problem, because now I have two number which have the same definition, is that plus 0 and minus 0, they have the different value. It's not acceptable. And problem number 2 is that arithmetic is cumbersome, means that if I have the 4 minus 3, it's not equal to 4 plus minus 3. Second problem. See, I show here 4 plus 3, it should be 7. I can convert it to binary and it's okay. 4 minus 3, minus 3 in my logic is that the last bit is 1, MSB bit is 1 here, and the number is 3. This is 3 in binary. Okay. Now, if I want to do the summation, 4 plus minus 3, it's become 1, 1, 1. But real minus 3, it's something like that. Because what I expected 4 minus 3 should become 1. This is the right value, but this is not wrong. It's not right. Okay. Same. Let us see. Minus 4 plus 3. Minus 4 in my previous analysis, the last bit should become 1. Okay. This is minus and this is 4. This is plus and this is 3. Minus 4 plus 3, if I do the addition, it's become 1, 1, 1. But real minus 4 and plus 3, it should become like this because I should have minus 1. Yes, then something is problematic with this one. What we can do, let us go for second approach. Second approach is using the one technique or one method, which based on that, we can have the ones complement. Ones complement, even it has some mathematical definition that I bring in your PPT, and you can read it proper. Even your math teacher can teach you why we have that, which we are not going to prove it. Okay, we're just going to use it in our subject. We don't have the mathematics subject. It's nothing but convert whatever zero that you have inside your number to 1, and whatever 1 that you have converted into 0. Okay, let us see. Suppose I have 0, 0. If I want to take the ones complement, I should do 1, 1, 1. Okay, plus 1, it's become 0, 0, 1. Then minus 1, whatever 0 I have, it's become 1, and whatever 1 I have, it's become 0. Okay, next one, plus 5, this is 5. Then plus 1, whatever 1 I have, it's become 0. Whatever 0 that I have, it's become 1. See, like this. Then there is one little bit problem. Can you tell me what is that problem? See, suppose I want to do the 4 plus 3. 4 plus 3, it's become 7. Okay, no problem. If I want to invert and add carry, suppose 4 minus 3, it's become like this carry. And if I want to do it with invert and add like that, it's become minus 1. Then it seems that little bit once complement is work. But little let me tell you the mathematics behind that, how it will work. Minus means that once complement is nothing but do the subtraction for 1, 1, 1 in the minus the real number. Okay, suppose I have the number 7 in the decimal, and if I want to know it from the what is the ones complement for that, I can simply do this. One 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 minus 0 1 1 1. Can you please do it? Do it with piece of hand. Okay. Let us continue. But what is exactly this 1 1 1 in the base of 2? 1 1 1 is in the base of 2. You know that 1 less than 1 0 0 0 in the base of 2 is equal to 2 rises by 4, means that the number of the bits minus 1. And minus 1 is representing by something like this: 2 power by 4 minus 1 minus y. And we have some class which our mathematics proof will shows that if x is less than y, then than 0, then there will be no carry from 4 minus 1 plus x minus 1. And then just add some representation to get the correct negative number. We can say that if x is greater than 1, then x minus 1 is greater than 0. Then there will be the carry, and performing the end round carry subtraction, 2 rises 4 and add 1. Then if we do the subtraction of 2 minus 2 power by 4 minus 1 from 2 power 4 minus 1 plus x minus y, Um, this is the case that we can have one complement, and in the other case that if x is equal to 1, then the answer should be 0. Then we can get 1 1 1 1. This is the one. Then what is wrong if this one's complement working fine? Why we need another approach? Because the main problem is here, plus 0 and minus 0. Then let us review. The first things that we save with the magnitude and the sign, it shows that we had two problems. One is that with the 4 minus, suppose, minus 3, and 4 plus minus 3 was problem, and we had two problem for plus and minus 0, which plus and minus 0 problem solved by one's complement. uh, no, it's remain with the one's complement, and 4 plus minus 3, it's solved by one's complement. Then we need another approach, which is more and most better things, which we call it 2's complement. What is 2's complement? 2's complements, it's something like we will take one's complement, or in the other way, we will convert 0 to 1 and 1 to 0, and then plus with 1. This is nothing but 2's complement. Then what will happen for the negative number? Negative number is something like this. Suppose if we have 7, uh, I can have 0 1 1 1, and if I want to convert it to the ones complement, it's become 0 0 1, and then plus 1, we can have 1 1 0 1. It simplifies the arithmetics, and only we have 1 0. Okay, let us do once more our repeated example, but now this time with 2's complement. With 2's complement, if I have 4 plus 3, 4 I can convert it between 0 1 0 0, and plus 3 is plus 0 1 1, then it's become 7. It's okay. 4 minus 3, it's something like that. That the first number is 4, second number is minus 3, okay, which we have dropped the carry. And if I want to invert and add minus 4 plus 3, I can see that the result is okay now. We have the same mathematical proofs for the 2's complement, and it shows that how it will work. Here, if you see, the basic analysis is based on positive number of y, which with the b bits that we can put inside this formula, 2 rises, 2 power with the b minus 1 minus y can be our 2's complement. One representation of the 0 we have, we can enable the subtraction operation by considering the addition of positive numbers with a 2's complement number. And we just only need addition. MSB also indicates the signs of the number. Then 2's complements, it's something like that, 2 power by b minus y, and this number have the same remainder, which divided by 2 power by 1. These are the mathematical proofs, but you can read it, and also I put it here for you, that we can see that applying the representation of x and minus 1, where we have x and y are positive number, we can get x plus 2 power by b minus y, which is equal to 2 power b plus x minus y. And if there is a carry, that means that x greater and equal to y, and dropping the carry yields x minus y. If there is no carry, then x minus 1, then we can think of it as 2 power by b minus y minus x, which is the 2's complement representation of negative number resulting from x minus 1. Only need one type of hardware and process now to add both signed and unsigned numbers now. Some definition we have that we should remember now, and maybe we will use later on. One is that overflow, that answers only connect which mod by 2 power by b, means that summing of two positive numbers can give the negative result, and summing two negative numbers can give the positive result for us. Something like that. 4 plus 6 plus 4, which can come as minus 6, and minus 6 minus 3, which can come to the positive 6. I will talk more regarding the overflow concept for you later, and some miscellaneous things that we can use. Okay, uh, then what we learn here today is that there is we can compare all our understanding for today. It's something like this. Let me check first with the ROI that it's coming. Okay. If I have the 4 digit, we can have something like that. I want to show the minus 0 and plus 0, that what will happen in this case. And between 0 to suppose number 8, and plus means that plus 0 to plus 8, minus 0 to minus 8. How I can show them? First of all, we say that with the sign and magnitude method, we have the MSB bit, which based on that we will shows the last bit or most significant bit. If it's 1, it means that my number is 0. You will see 0, 1, 2, -2, -3, -4, -5, and so on. And with the analysis of the plus number, if the MSB part is 0, it means that the numbers is positive for me. Then you will see that plus 0, plus 1, plus 2, plus 3, plus 4, plus 5, and plus 6, and plus 7, and so on. Then what is the first complement? First complement is that whatever number that I have in positive, if I convert it from 0 to 1 and 1 to 0, it's become my first complement. See, suppose the minus 0. Minus 0 and plus 0 are exactly opposite. And minus 1 and plus 1, you will see that 0 it's become 1 and 1 becomes 0. As we say first complement, we don't like it because we have problem with minus 0 and plus 0. And 2's complement, it's better way. What is 2's complement? In 2's complement, we don't have the problem for positive 0 and negative 0. Okay. uh, then with the next things that I want to tell you, uh, it's some coding part, that some definition that we call it BCD or binary coded decimal. In that, we will show the number just from 0 to 9. Okay, and this is nothing but just conversion the positive number. We don't have minus BCD numbers meanwhile. Okay, then one more definition that we should note is positional notation, which if we want to show the positive number n, we can show it as this formula, which in that R is the radix or base of number system, n is number of integer digits to the left of radix point, m is number of fractional digits to right of the radix point, AI is integer digit I, AJ is fractional digit j, and AN minus 1 is the most significant digits, and AM is least significant bit. Just I will tell you this formula to remember. No need to mark them, no need to memorize them. Meanwhile, we have better method to memorize and remember them. Okay, just these are the mathematical things behind this. Suppose if I want to say the radix complements definition, we can have this formula, which is n brackets with the r, which shows the radix components of the n, and nr will shows the original number of r, which in this formula radix or base is r and number of digits are n. Note that n added to these complements is equal to r power by n, and if we ignore the MSD or most significant digits, uh, this is just zero for us. Okay, uh, for today, I think it's okay for us. What we learn is that we learn that how we can take the two's complement with some method. The best method is that, my friend, just take the one's complement, add it with one, the blue one that I show is here. We have some more methods, suppose like this. We can have the formula of 2 rises by n minus n with base of 2. Another one is that we can leave all the least significant zeros and first one unchanged and then flips or complements the bits for all. I just prefer this method. 2's complement is nothing but 1's complement plus 1. Simple, direct, and best way. Okay. One more question. Can we have more complements? Suppose complement of 10 or complements of 9. What we should do? For complements of 10, just we will put the 10 and we will count the digits. Suppose in this example, I have 6 digits. We can have 10 power by 6 minus the number. Then 10 power by 6, it's become 1 with 6 number of 0, and then we can minus with the real number, and then the number will come out. And complements of the 9 is 10 minus 1, and then minus the number that we can do. Other way of the 9 is that we can complements a 9 plus 1, then it's become complements of 10. Same thing that one's complement, two's complement is one's complement plus 1. Then 10 complements is 9 complements plus 1. Okay.